Hello everyone. In this presentation, we are going to understand how to switch on an individual appliances using 8051 microcontroller through port 0. So what you see in the screen here is through port 0, 8 LEDs are connected. Those 8 LEDs are switched on in some pattern. So what is the pattern? What do you understand from the pattern means? The first LED is on, then second LED is on, then third LED is on, then fourth LED is on, then finally the eighth LED is on. So switching on the appliances in sequence. In so many applications, there is a need to switch on the appliances one by one in sequence. So to mimic that, these 8 LEDs are glowing like this. If you see his, the first top LED is glowing first, then the second device is on, then the third device is on, then the fourth device is on, then fifth device is on, and finally eighth device is on. While switching off, we are doing it in the opposite direction. 8th device off first, then 7th device off, then 6th device off, then 5th device off, then finally the first device off. So switching on the devices one by one in sequence, and then switching off the devices one by one in sequence in the opposite order is the objective. But as a fun, if you want to relate with some magic application, means it is something like a sliding door, single sliding door, which is closing and then it is opening. You see, sliding door is closing and then sliding door is opening. So the single sliding door is closing and single sliding door is opening. Something like this also we can mimic with, relate with some application. So it is something like sending out the value from port 0 in some pattern. What is that pattern? What is that value? When you see the code, you can able to understand this clearly. While coming to this code, as you see here, it's very simple as usual. What we do here, we use to write a program like this. As usual, we know hash include reg51.h, which is our header file for our 8051 microcontroller as usual. And then we have a small delay of some small delay function or delay routine, and void main while 1 as usual. And then if you see here, so through port 0 we are giving out logic 1, that is hexadecimal logic 1, and then hexadecimal logic 3. So logic 3 means switching on 2 LEDs. After some delay, switching on 3 LEDs, which is 7. After some delay, switching on 4 LEDs, which is 0F. After some delay, switching on 5 LEDs, which is 1F. And similarly, 3F and then 7F and then FF will switches on 8 LEDs in sequence, which is something like closing the door. Then again, if you look at here from FF, if you see here from FF, slowly you are switching off one by one the LEDs from FF, then 7F, then 3F, then 1F, then 0F, then 07. So for all the values we are calling the same delay, and finally we are having some big delay just to show that the door is closed for some. After closing, it is waiting for some time, and then after opening, it is waiting for some time. So this is the code for this. And then after compiling and building, so we are using the Nuvoton environment to download the code from the host machine to the target machine. So with the Nuvoton environment, you are selecting this hexadecimal file, and then you are downloading this. How to download? So by pressing the reset button, you are able to see the hexadecimal file is downloaded to the flash memory of the Nuvoton IC, and then you will get a pass notification. So when you click OK, we are able to see closing the door and then opening the door. So this is how the individual devices can be switched on and switched off independently with the help of 8051 microcontroller. That is what we have understood from this experiment. Thank you.